The Marine corporal pressed his back against the mud brick wall. Across the alley, enemies prepared a rocket launcher on the roof. His rifle could not solve this problem. Someone handed him a collapsed tube. The corporal pulled the rear section backward, and a sharp plastic click echoed as the cover snapped open. He rested the extended cylinder on his shoulder. It weighed under 2.5 kilograms. That equals just 3 loaded rifle magazines. He fired a 66mm rocket through the window from 40 meters away. Modern war expects network sensors and smart munitions. Instead, this firefight ended with a disposable tube from 1963. The M72 light anti-armor weapon should have vanished decades ago. This 66mm round erased generations of staff planners' work. Generals proved the weapon obsolete with charts, yet soldiers kept packing it. Beginning in the early 1980s, the Pentagon tried to kill the system. They launched the Viper program. Development consumed nearly $1 billion before cancellation forced a rapid pivot. Next came the heavier AT-4 system. Replacement budgets swallowed tens of millions more, and the AT-4 assumed primary anti-tank duties. But frontline infantrymen ignored these procurement cycles entirely. They still carried the cheap M72 into the dirt. Bureaucrats simply misunderstood trench reality. The military complex built the perfect answer, and then the enemy changed the question. Staff models failed to predict the actual future of warfare, but during the late 1950s, their logic remained sound. 72 hours. That was the strict time frame allowed for Soviet armored groups to cross the border and reach the banks of the Rhine River. Moscow assembled the largest armored force in human history, built specifically for a rapid push into Europe. Thousands of T-54 and T-55 tanks formed dedicated shock armies designed to exploit the Fulda Gap. The doctrine relied on a heavy density of armor moving forward at 50 kilometers per hour. The deep roar of thousands of diesel engines drowned out any defensive commands across the sector. NATO planners realized conventional infantry could never hold this line. One tank every 30 meters across a 40-kilometer front. This continuous moving wall of steel stretched the exact distance from central Paris to its farthest outer suburbs. Stopping that wave required a shift in tactical calculations rather than traditional courage. The classic anti-tank teams of the Second World War would die before unpacking their heavy launchers. The old bazooka demanded 2 operators and relied on complex drills that collapsed under artillery barrages. Every infantryman needed an individual weapon he could fire independently in the first seconds of contact and immediately discard. Soviet generals assumed no lightweight single-use weapon existed to counter their spearhead. Throughout the end of the decade, their assumption remained correct. By 1963, Soviet intelligence discovered that such a weapon had finally appeared. An American infantry squad crouches in the summer dust. It is 1950 on the Korean Peninsula. They watch an advancing T-34 tank roll down the dirt road. A 60mm bazooka fires its shaped charge at the approaching steel beast. The sharp metallic clang of the rocket ricocheting off the sloped frontal armor rings out. That sound instantly shatters an outdated tactical doctrine. The old World War II launchers are practically useless. The mathematics of European deterrence were actually born from a very real disaster on the Asian peninsula. The heavier 89mm super bazookas were quickly rushed to the active front lines. They performed much better against Soviet armor, but the fundamental flaw remained unresolved. A weapon demanding a 2-man crew and setup time proved entirely wrong for mobile combat. The required coordination turned the operators into sitting targets. After-action reports analyzed these engagements over the next 9 years. Pentagon bureaucrats systematically quantified the exact cost of relying on heavy crew-served platforms. The conclusions were strictly mathematical, completely stripped of any battlefield panic. Without independent armor-piercing capabilities, defensive lines simply crumbled under mechanical pressure. The infantry surrendered their positions. The Pentagon converted the collapse of those defensive lines into a single engineering demand: 2.7 kilograms of maximum allowable weight. A soldier would only carry an anti-tank weapon if it did not force him to abandon his essential survival gear. This realization established a new mechanical philosophy for the early 1960s. The manufacturing process eliminated the heavy launch rails of previous generations. Factory workers inserted a 66mm shaped charge rocket directly into a lightweight launcher. They permanently sealed the warhead inside the smooth fiberglass cylinder, removing any option for the infantry to disassemble or modify the weapon in the field. The deliberate absence of delicate glass optics and fragile batteries meant the hermetic tube could sit in cold storage for decades without degrading. At a production cost of roughly $30 per unit, the M72 light anti-tank weapon became a disposable item on the battlefield. The operator simply pulled the safety pin, extended the inner tube, and deployed the rudimentary pop-up sights calibrated up to 300 meters. The warhead could punch through 300 millimeters of rolled steel armor. By 1963, the United States Army officially adopted this fiberglass tube to equip millions of infantrymen against an armored invasion across the European plains. It was the precise tactical answer for a global conflict. That war never happened. The anti-tank weapon built for the open European plains of the 1960s waited 4 long decades. Its real battlefield materialized in the concrete alleys of the Middle East. November 2004 marked the beginning of Operation Phantom Fury in Iraq. 10,000 American soldiers and Marines pushed into Fallujah. Before the military assault, the sprawling city held a civilian population of around 300,000 people. It was a massive urban labyrinth. Insurgents spent 6 months turning residential blocks into a contiguous defensive network. They had no armor. They relied on standard AK-47s, RPGs, and an intimate knowledge of the local terrain. M1A2 Abrams tanks rolled down the main thoroughfares to anchor the American advance. The Marines prepared for intense infantry combat against mobile fighters. Instead, the advancing units hit concrete fortresses completely immune to standard fragmentation grenades. Insurgent fighters engaged the approaching forces through narrow loopholes. They punched these firing ports directly into thick structural barriers to shield their gunners. Heavy rifle fire simply sparked and ricocheted against the masonry. Thick concrete dust hung in the narrow alleys long after every failed explosion. The regional architecture was designed to survive extreme desert climates and centuries of conflict. The walls were thick. This Middle Eastern construction proved significantly harder for a foot soldier to crack than traditional tank armor. Pinned down in the streets, infantry squads searched for a way to break through the wall. How do you eliminate a machine gunner behind a meter-thick reinforced wall when heavy armor support remains 2 blocks away? An M1A2 Abrams tank possessed the firepower to vaporize a fortified insurgent position in exactly 4 seconds. However, the 60-ton chassis physically could not maneuver through tight urban layouts and narrow alleys at the speed of a foot patrol. The infantry units began tearing into their operational reserves of disposable plastic tubes. The old tactics collapsed. Marine platoons carried the M72 LAW not to destroy enemy armor, but to breach concrete structures at point-blank ranges. They encountered a physical reality that Pentagon strategists had missed during the Cold War. The focused copper-shaped charge, precision-engineered to melt through the sloping steel armor of a Soviet T-55 tank, bogged down and dissipated inside dense cinder blocks. A narrow jet stream designed for deep armor penetration lacked the explosive concussive force required to collapse heavy building masonry. The age meant nothing. The warhead chemistry was the wrong tool for this specific geography. Formal field reports from multiple combat battalions traveled up the operational chain of command between late 2004 and early 2005. They demanded an immediate engineering solution. The squads requested the exact same lightweight disposable format. They needed a dedicated bunker-busting explosive payload instead of an obsolete anti-tank penetrator. The frontline request landed squarely on the desks of defense procurement officials. This department had spent 2 decades attempting to retire the launcher. The Pentagon bureaucracy documented the field data and officially acknowledged that a 50-year-old disposable format remained the correct answer. Combat requests from Iraqi streets finally reached the procurement officers who had tried to bury the launcher. The paradox was immediate. Norwegian engineers delivered a completely new weapon without altering a single gram of the familiar green tube. Nammo, a Nordic defense contractor with facilities across Europe, had purchased Tally defense systems. They secured the production lines. The resulting M72 A7 variant retained the exact same plastic casing and firing mechanism. A soldier still carried about 2.5 kilograms, but the payload inside was entirely different. The factory swapped the old shaped charge for a thermobaric explosive mixture. A heavy shockwave now cracked concrete walls from the inside out. This European contract proved that the global defense industry could rapidly supply a highly specific infantry demand. The American procurement debate had completely missed the actual value of the weapon. The old launcher was never just a rocket. It was a rapid delivery format for an explosive solution. A soldier needed 1 shot and 0 preparation time. The heavier AT-4 launcher weighed almost 7 kilograms. A rifleman had to stop, set it up, and deliberately aim it. The old lightweight tube was different. A soldier grabbed it when the tactical situation demanded an explosive decision within 5 seconds. The ground reality forced a new tactical approach. The primary battlefield threat permanently shifted from Soviet armor to urban fortifications. The new warhead did not merely breach concrete walls, it collapsed the timing model of the enemy defense. Why did heavily fortified insurgent positions suddenly begin to fall? Their defensive strategy relied on the minutes Americans needed to summon artillery or position heavy teams. Calling air support consumes precious minutes, granting fighters time to inflict casualties and relocate before the strike. Insurgents had carefully studied standard infantry capabilities. They mapped the exact blast radius of an M203 grenade launcher against hard cover. They understood that surviving an ambush at a distance of 20 meters required moving faster than incoming radio calls. But they failed to anticipate a direct-fire rocket appearing in the hands of a single rifleman without any crew setup. Soviet planners in 1963 calculated tank assaults assuming regular infantry lacked instant armor-piercing firepower. Insurgent commanders in 2004 made the exact same tactical miscalculation regarding urban strongholds. The M72 shattered this established timeline. A soldier deployed the tube and fired within 5 seconds. No heavy weapons team moved into position, and no operator requested coordinates. The threat remained invisible until the moment of the blast. No one prepares for that. A rifleman steps into the street. He carries a plastic tube strapped to his pack. It holds an answer the Cold War funded 60 years ago. 5 seconds to fire without preparation is a metric headquarters ignores. They calculate armor penetration and maximum range. The infantry calculates survival. The Pentagon tried to replace the design for decades. Every new system failed the street-level test. The AT-4 is heavier. The Carl Gustaf demands a dedicated crew to reach its full potential. Then comes the Javelin complex. A single launch costs tens of thousands of dollars. The missile requires a clear thermal signature to achieve target lock. That technology is useless when breaching a concrete wall at 40 meters. The M72 survives because it fills a specific tactical void. It occupies the exact space between a thrown hand grenade and a heavy guided complex. Modern conflict shifted from open plains to narrow urban corridors. The weapon crossed this divide without changing a single internal part. It remains light, simple, and instantly ready for deployment. 60 years of procurement cycles and massive defense programs failed to produce a better alternative. The true test of modern combat is never the expected war. It is the sudden reality of a blind corner. A single man drops to his knee, extends the tube, and pulls the trigger. The outcome of the fight rests entirely on those first 5 seconds of contact.